County has an unemployment rate of 7.1%. A random sample of 16 employable people are picked at random from the county and asked if they are employed. Round your answer to 4 decimal places. Find the probability that exactly 3 in the sample are unemployed. That is, they want you to find the probability that 3 of the 16 people they sampled are unemployed. So this looks like this. The notation for that looks like P, and sometimes they do X is equal to 16. The probability that the number, when they use this X value for the number of successes, the probability the number of successes is equal to 16, exactly equal to 16. That is equal to the binomial, you use it on a calculator, it's binomial PDF. PDF is for exactly one value. Okay, and then you always are going to enter the number of trials, the number of in their sample, 16, and then you're going to enter the probability of success, which is, you have to move this decimal twice, but it's 0.071. So 0, you could do a leading 0 if you like it. It looks like 0.071. To be very careful, and a lot of people accidentally move that decimal place wrong. And then the value that you want to put next is the X value 16, or sorry, there's a number of successes that you want. Oh, sorry, 3. I'm sorry. So the number, they want exactly 3 that are unemployed. And they're saying the unemployment rate, or the probability that somebody will be unemployed, is of this 0.071. So the probability that they will have exactly 3 people unemployed, it looks like this. The probability that X will equal 3, be exactly 3, and the answer will look like this on your calculator. And if you can enter in these numbers, then you can get the right answer. So on your calculator, it it looks like this. You go to second vars, and then it gets you to the distribution list, and you have to keep scrolling down, until you get to something that says binomial. It's binom PDF. And you just press enter once you have got to that one. And then next, sometimes some calculators prompt you how many trials or how many are in your sample. The P is the probability for success. So our trials are 16 for this problem. Then the probability of success was bet 0.071. And then our X value was 3, exactly 3. And then we just go down to paste, and then press enter. You'll use the arrows to go down to paste and press enter. It'll paste it into the calculator the way it's supposed to look. So like I said, ours is not going to look like 9.626. Ours is going to look like 16, the 0.071, and then 3. That's what's going to be in our parentheses. And I said, this is just what the screen kind of looks like and how to do it on your calculator, okay? And then it looks like, then you just, once you have that on your screen, then you would just press enter, and then this would be your answer, and make sure to round it to the right decimal place they're asking for. And that's how you do it on your calculator. All right. So that's how you would do this first one, part A. Okay, the second one is find the probability there are fewer than 4. Okay, so fewer than 4 people that are unemployed would mean either 0 people unemployed, 1 person unemployed, 2 people, or 3. That's the values that are fewer than 4. So what you need to do is find the probability that the X will equal 0, probably that there'll be no people in a sample within a sample of 16 that have that are unemployed, and you need to add it to the probability that there'll be exactly one person unemployed in a group of 16 plus the probability that there'll be exactly two that are in 16 that will have be unemployed plus the probability that of 3, and you have to add those all together. And so you could do, do it like you did in part A, but just do it for 0. So where you see the 3, you're going to plug in 0 and you could find the answer. And then you could do the same thing again for part A for 1, find the answer. And then do the same thing again part A for 2, and you're going to put wherever you see a 2, you're going to put or 3 with, you're going to substitute with wherever you see a 3 in part A, you substitute with a 2 and do it. And then the same thing with we already did 3, but we can add the answer we got for part A to this final answer to get the final answer for part B. Okay, that's one way of doing it, adding all of those together. Or there's a cumulative function that automatically adds the probability of the number given plus the probability of all of the other numbers smaller than it. So it will give us this answer in one swoop. So that function is called binomial CDF, cumulative distribution function, which means it adds that value and all the values smaller than it, that whatever get value you give it. So the way that would look is it looks to find, okay, let's write this in math sentence. What are they trying to ask us? Fewer than 4 means that the value is less than 4. It also could be, we could also say this because there's no numbers between, these are all whole numbers. You could only have whole number answers that the X could be less than or equal to 3. It would be the same thing as saying less. Fewer than 4 is 3 or less. Okay, that means the same thing here because you can't have when you sample 16 people, you can't have 3.5 people that are unemployed because you can't have half of a person in the situation. So this value X less than or equal to 3 is the same expression, or saying 3 or fewer is the same as saying fewer than 4, because fewer than 4 does not include 4. It means strictly fewer, smaller than 4, right? So they really want us to do 3 or less. So what we're going to do is we're going to put in binomial CDF because this gives us 3 and everything smaller than 3. And it's just another option on the calculator. You need to scroll a little further down the calculator to do. But we're going to say the number of trials is 16. And the probability of success is still the 0.071. And the value that we want to find that value and smaller is 3. And there we go. So that's part B. Okay, then it says find the probability that there are more than 1 in the sample of that are unemployed. Now we have a function that will take and add such a value and all the values smaller, but we don't have a function that will give us given a certain value and everything larger. It'll sum everything larger. We don't have that. So the only way we can do this is by using the complement. So find the probability that there are more than 1. That does not include 1. So that would mean find the probability that of 2, because 2 is more than 1, plus the probability of 3, plus the probability of 4, and so on. Plus the probability of, and I'm using this interchangeably, like the probability, when I just say probability of X equal to 2, that's the same as probability that it's 2, okay? I'm just like saving a little bit of space here, okay? Press the probability of 5 plus the probability dot, dot, dot. We would continue that all the way up to the probability of 16, right? We would have to find all of those individually and add them together. That's one way of doing this problem. And of course, these dots mean everything between probability of 5 and probability of 16. So probability of 6, probability of 7, probability of 8, so on until we get to 16, right? So that's a lot to calculate. So a better way of doing it is think about, well, what's the opposite of more than 1? The opposite of more than 1 would be 1 or less. So that makes that is the complement. All of these together, like the probability of 0 people being employed in 16, plus the probability of 1 being unemployed if it's 16, all of those together have to equal 1 whole, because it's the total all possible outcomes that that could possibly happen. So all of these probabilities have to add to 1 whole. So what we can do is we can calculate just these two, and then we could subtract that from 1 whole to find the probability of all of those. Okay, because that's the complement rule. It's just okay, and so that's what we're going to do to find the probability of 1 or smaller and smaller. You just do so the probability of more than 1, or you could say x greater than 1. Another way of saying that is probability that x is greater than 1, right? Well, that is equal to 1 minus the probability that x is less than or equal to 1. So if I want to find the probability of x less than or equal to 1, that is equal to binomial CDF. So probability of x less than or equal to 1 is equal to binomial, because it's 1 and smaller than 1, so binomial CDF, and the number of trials is 16. The probability for success is 0.07 and 71, and then the number of successes and that value and smaller that we want is 1. So we calculate what that is, and then we just take it away from 1, and that's how we do this second part right there, or third part. Okay, and then this last part says find the probability that there are at most 4 in the sample that are unemployed. So we have to think about what at most 4. So at most 4 means 4 or fewer. So that's just probability of x being less than or equal to 4. At most 4 means 4 or fewer. It's probability of x being less than or equal to 4. That's going to equal to, that's because all the less than ones, x less than a value, or we can use CDF. So binomial CDF 16, we're going to enter 16, we're going to enter 0.071, and we're going to enter 4. And there we go. That's our answer. All right. I hope you found this helpful. Have a great day. Bye.